Kubernetes admission controllers are vital components in any secure setup, as they enforce critical security policies and governance rules directly within your Kubernetes cluster, ensuring that all resources meet your standards before they are created or updated. Acting as intelligent gatekeepers, these controllers intercept all incoming requests to the Kubernetes API server right before objects are persisted into ACT, meticulously checking for compliance and blocking any misconfigurations that could introduce vulnerabilities into your environment. However, one of the most significant risks in Kubernetes security is the potential for admission controller bypasses, which can completely undermine your carefully constructed security posture and expose your cluster to serious threats. If a malicious actor or even an unwitting developer manages to circumvent these essential checks, they could easily deploy non-compliant workloads or outright malicious pods, leading to severe threats like privilege escalation, data breaches, or full infrastructure compromise. To illustrate this danger, imagine a well-intentioned policy specifically designed to block all pods from running with root privileges, which is a fundamental security best practice recommended by Kubernetes security guidelines. In this demonstration, we'll clearly show how a simple misconfiguration or a cleverly crafted pod definition can be used to bypass this critical security check, allowing unauthorized elevated access. A seemingly innocuous change in the pod's security context section, such as relying on an overlooked default setting or even a subtle alteration in how containers are defined, can create a dangerous opening for privilege escalation. For instance, consider a policy that strictly checks for explicit declarations like run as user, 0, or run as non-root, false, but fails to account for containers that inherit root privileges directly from their base image without explicit overrides, enabling an easy bypass. This oversight allows a workload to execute with highly elevated root privileges, directly contradicting the policy's intent and creating a significant, exploitable vulnerability in your cluster's defenses. To effectively prevent such dangerous admission controller bypasses, implementing a comprehensive, multi-layered security approach is absolutely essential for protecting your Kubernetes environment. Start with the first key practice. Always deploy multiple admission controllers in your cluster, each responsible for enforcing different, complementary aspects of your overall security policy to provide overlapping protection. This built-in redundancy is crucial because it ensures that even if one controller is cleverly bypassed through a specific technique, the others can still detect and block the malicious activity effectively. Secondly, make it a priority to keep both your admission controllers and the entire Kubernetes cluster fully updated with the latest versions, as this patches known vulnerabilities and closes off common bypass paths that attackers might exploit. Additionally, commit to regularly auditing your configurations, policies, and pod security standards to proactively identify and seal any potential loopholes, misconfigurations, or drifts from best practices. Leverage automated tools like policy scanners and validation frameworks, such as OPA Gatekeeper or Caverno, to continuously test your policies against known bypass techniques and ensure robust enforcement. Finally, invest in educating your development, DevOps, and operations teams on secure coding practices, along with Kubernetes-specific security best practices to foster a culture of security awareness across your organization. In summary, robust admission control mechanisms are absolutely paramount for maintaining a secure, compliant, and resilient Kubernetes environment in today's threat landscape. Take action today by thoroughly reviewing your cluster's security setup to confirm that your admission controllers are effectively safeguarding your workloads against bypass risks and potential exploits.